Angles today, and so this is from the past, but we kind of still need to talk about it. If we have like measure of angle A equals the measure of angle B, and angle A is congruent to angle B. So this would be the definition. You guys remember yesterday we had the definition of congruent segments. If the segments are equal length, then they are congruent segments. This one is if the measure of the angles are equal, then they are congruent angles. This is the definition of congruent angles. Okay, these are numbers like 50 degrees or whatever. These are things, angle A and angle B. All right. You guys know what adjacent angles are?
Like angles that are on like this, like.
Okay, adjacent angles share a vertex and a side. Okay, so these two, angle 1 and angle 2, are adjacent angles. They share a vertex and a side. So that's the definition of adjacent angles. Right next to each other, sharing a side. If C is in the interior of angle ABD, interior just means it's somewhere in here, then angle ABC plus angle CBD would equal what?
Angle ABD.
Angle ABD.
Transitivity.
Okay, that is called the angle addition postulate. This little angle plus this little angle equals the big angle.
So it's not transitive?
It's called angle, no. Transitivity, transitive property is if A equals B and B equals C, then angle addition postulate, because you're adding the two little angles to get the big angle. Do you guys remember what postulate meant? It's something that we can't prove is true, but we just assume it is because it seems obvious. This plus this equals that. So if this was like 40 degrees and this is 50, well, 50 degrees, then the big angle would be 90.
Never to assume, so.
What says what?
My Mimi says never to assume anything.
Okay.
Well, your Mimi's wrong.
So if two angles together make a straight line, what do you think we know about those two angles? Yeah, they're defined as if you have two adjacent angles that together make a straight line, they're called a linear pair. So that's like a definition. These two angles make a line together, a linear pair. The fact that they have to add up to 180, like if this was 60 degrees, what would this one have to be? 120. Okay, that's actually a theorem. It's called the linear pair theorem. Linear pairs, maybe I should say, always add up to 180. That would be the linear pair theorem. Because they make a straight line. Kind of obvious, but still a theorem. Okay, what else? I don't think we've talked about this, but maybe we have. Probably not. Alright, let's say that this angle is maybe 30. We'll say it's, 30 is fine. Okay, if that angle is 30 degrees, what would angle 1 have to be?
60.
No.
50. Or 150.
Why is it 150?
Because 180 minus 30 is 150.
Yeah, these two angles together make a linear pair, right? So they have to add up to 180. So if this is 150, what's this angle 2 going to be?
30.
30 for the same reason, right? And if this is 30, what's angle 3?
150.
150. Okay, that happens every time. That's going to happen every time. So what it means is these angles opposite of each other always are going to be congruent. When lines intersect, the opposite angles are always congruent. And those angles are called vertical angles. Okay, so angle 1 is a vertical angle with angle 3. Angle 2 and angle 4 are vertical angles. Alright, and vertical angles are always congruent. That is a theorem.
I'm still confused how you got the 150.
Together, Jay, these two angles up here
Yeah.
make a straight angle. Do you see it, a straight line?
Yeah.
So how many degrees are in a straight angle?
180.
180. So if that's 30, this one's going to be 180 minus 30.
Oh.
You get it?
Yeah.
We're going to use that trick a lot this year, so. Okay, and then, you guys might remember this from like 8th grade. Well, you might remember after I remind you. I know you better remember. Okay, the word complementary, that actually has a lot of not math meanings, but it's got a geometry meaning also. Things that are complementary just go well together, like peanut butter and jelly or colors or whatever. Let's see. So we have like a 40-degree angle and a 50-degree angle. These would be complementary angles because complementary angles add up to 90 degrees. Okay? Complementary angles add up to 90 degrees. It's two angles together make 90. Okay? So they might look something like this, just randomly floating around. But they also might look something like this. Okay, there's a 90-degree angle. Okay, now those two angles would have to be complementary, right? Because together they make a 90-degree angle. Complementary angles add up to 90. So guess what this means then?
Okay, 180.
Yes. Add up to 180 degrees. So that could look like 100 degrees, 80 degrees. So these would be supplementary because they add up to 180. But it also could look like, guess what?
A straight line with a 9 over it.
Okay, it could look like this. Like 70 and 110. Okay, so linear pairs are always supplementary because they always will add up to 180. Linear pairs are always supplementary. That's a theorem. We kind of already talked about it, but yeah, they always add up to 180. Okay, if you forget which is which, they're kind of in alphabetical order, like complementary before supplementary, 90 before 180. Okay? Or you can just flip back and look in your book on the previous page for now. You will need to have it memorized like for the test though. Complementary, supplementary. All right, did we get them all? We got the important stuff. Something I did skip, this is kind of silly, but I'll go ahead and say it real quick. If we have two congruent angles, what is the complement of this angle going to be? What's the complement of 50 degrees? 40. Because adds up to 90. What's the complement of this? 40. So complements of congruent angles are themselves congruent, right? That makes sense? Complements of congruent angles themselves have to be congruent. What about supplements? What's the supplement of 50 degrees?
130.
That'll be 130. Supplements of congruent angles are congruent. It's kind of an obvious statement, but sometimes you have to use it in a proof. So, anyway, that's a couple things. A couple other things I'll throw out there. All right angles are congruent to each other. Duh. Okay, this one might be a little bit tricky for you guys to figure out. Congruent supplementary angles have to be what kind of angles? Congruent supplementary angles would have to be what kind of angles? What's congruent mean? What's congruent mean? The same. So if you have two congruent angles and they're supplementary, what's supplementary mean? They add up to 180. What has to be true about those two angles? if they're the same and they add up to 180,
190.
it'd have to be right angles, yeah. So congruent supplementary angles are right angles. The other one is kind of like it. If you have a linear pair and one of them is 90, guess what? If you have a linear pair and one of them is 90, the other one's 90. Kind of the same thing, you said a little differently. So, yeah. Those are all theorems, but kind of a little bit obvious. Number 1. What kind of angles are angle GKJ and HKI? Alright, where's angle GKJ at? The top one, and where's HKI? The bottom. So what did I say those angles were called? This one and this one together? Vertical angles. And what do we know about vertical angles?
They are supplementary.
No.
They add up to 180.
No, that's what supplementary means. These two are not supplementary. They're congruent. Vertical angles are congruent. Remember?
Oh, yeah.
We have 50, 130, 50, 130 thing. All right, number 3. Find the measurement of angle IKH. So IKH is down here. How do I find the measurement of that?
You do 180 minus 55.
180 minus 55, because these make a linear pair here. Make 180. So 180 minus 55 is 125 degrees. All right. Number 5. What is the measure of the complement of angle JKI?
35.
Okay. Yeah, JKI is this 55. So the complement means adds up to 90. So 90 minus 55 is 35. Okay, then it says, what's the supplement of that angle?
125.
Right. 180 minus 55 is 125. All right, number 7. Name 2 angles. Oh, that's number 6. Name 2 angles that are supplementary to angle FGE. I probably better draw this one. Okay, it has a 90-degree angle there, and then it does this. Darn it. And it does ACD. Alright, so number 7 says name 2 angles that are supplements of FGE. Do you guys see FGE, angle FGE in the picture? It's right FGE. Right there. Okay, so what did supplement mean again? Supplementary angles? They add up to 180. So what angle together with this angle would add up to 180? Okay, FGB. How did you know that? Actually, let me switch colors. Go ahead, sorry. Yeah, because together they're linear pairs, they have to add up 20. So he said angle FGB. There's one more in the picture. Right. So if you go the other direction, there's another straight line right there. So this would be a supplementary angle with that. So angle EGC. Okay. Number 9. Find the measurement. That little M in front of the angle, measurement, it means the measurement of the angle, like how many degrees it is. The angle itself is not a number, but the measurement is a number. Angle FGE. Alright, we were just talking about that angle. That's right here. So, yeah. Because they're, what kind of angles are these?
Congruent or vertical.
Vertical angles are equal, so yeah, it's 50 degrees. Number 11, measure of angle BGD. So right there, what'd that have to be? 90. 90 and 90 make 180, so it has to be a 90. All right, 12 says classify each angle by its measure. So what do you think they mean by classify the angle?
Like,
No, that would be like two angles are complementary, but how would you classify one angle? Roman, are you listening?
Yeah. Oh,
No, you're not. Okay, it means acute, obtuse, right, straight. Those things. Those are the classifications of angles.
So we don't have to write
like the
No,
number.
no. No, we already answered the measurements on 9 through 11. You just have to say what kind of angle it's. Okay, 13, reflexive property, but we're using congruent angles. Do you guys remember what the reflexive property was from a couple days ago? We might have used it yesterday, but you might have to turn a few pages back. Anybody reflexive?
It is A equals A.
A equals A, but we're supposed to use angles. So I'll just say angle A is congruent to angle A. It's a reflexive property for congruent angles. 15 says the transitive property. Oh, you should recognize this one. If angle A, what? Transitive property, what was that?
If angle A equals angle B.
Say congruent to angle B
Congruent B.
and
And congruent B.
Angle
or
B.
Angle B is congruent to angle C. Then angle A is congruent to angle C.
two, 17. Name the definition, postulate, or theorem. I don't think any of these are oh yeah, there is one postulate in there. So they're kind of describing like one of the rules or definitions we talked about today, and we gotta say which one it is. So 17 says if angle C and angle D are supplementary, then the measure of angle C plus the measure of angle D is 180. Okay, how did they know that those two angles had to add up to 180?
Because angle C and angle D are supplementary.
Because that's what supplementary means, right?
Yeah.
So if we're talking about the meaning of supplementary, we're talking about a definition.
I meant definition.
Definition tells us what supplementary means. So that is the definition of supplementary. And anything that's new, like the definition of supplementary, you just have to turn your page back one to find it. Any of these new things. There are a couple things that are old, but most of it's new. Number 19. If angle X and angle Y make a linear pair, then angle X and Y are supplementary. Well, we talked about that, but you guys remember what linear pair meant?
Linear pair means a straight line.
Okay. What's the definition or theorem or whatever that says linear pairs are always supplementary? Yeah, that was new, so it's just back one page. Yeah. Linear pair theorem. Okay, and I'm not like going forward, I'm not going to say you have to remember that's what it's called, but you do have to remember that two angles on a line make it 180.
That two angles. Oh, okay.
You have to be able to know how to use it. Yeah. Okay, 21. Okay, so in that picture on 21, what do we know about those two angles? 13x and 7x plus 6. What do I know about these two angles?
They're vertical angles.
So what do I know about vertical angles? They're the same. So what should I write?
13x equals 7x.
Yeah.
Or 7.
If they are the same, they are equal. Now we have an equation that can be solved for x.
Yeah.
So what should we do?
Distribute 7.
X is on both sides.
So subtract 42.
And
Subtract 7x.
isolate the x's on one side.
Divide by 42.
Now divide by 6. So x
And that.
is
7.
7. Well, that was actually that was the first question. What's x? Oops. Second question is, what's the measurement of angle AED?
Wait, where'd you?
ABC is down below the picture. Okay, so how do we find the measure of angle AED?
It's the same as.
It's
You'll plug. Okay, so it's the same as the top one.
so
So you'll just plug 7 in
times
for
13.
x.
Yeah, you can plug 7 in for x. So it's 7 plus 6 is 13 times 7 is
Good question.
91 degrees. Okay, then it says C, what's the measurement of angle CED?
Well,
CED.
So you're going to take 180 and then minus 91.
Right. This is 91, so this one will be 180 minus 91, which is
89.
see, this is not hard at all.
all right, but how would we set up 22 though?
Well, is it foil?
No. What do we know about those two angles? They will add up to 180, so how would we write that?
Plus, in parentheses, 9y plus 5 equals 180.
Okay, so in that case, how would we set up 23? What do we know about those two angles?
4z plus parentheses 7z plus 9 equals 90.
7z plus 2.
Equals 90.
Okay, yeah, they have to add up to 90.
What is it?
Now, are you looking at 23?
Yeah.
You see how they put that little red box in the corner? That means the big angle is a 90-degree angle.
Oh, no,
So that means the little two angles. Now, when we have a plus parentheses, does that do anything?
Nope.
You're just adding that and adding that. So really, no. When you have a plus in front of parentheses, you don't really need it. They just like grouping that together so it looks like one thing, but it doesn't really do anything. So now what?
You plus the z's together, so, and then minus 2, and then 11 divided by 8.
Okay. And that's the answer to A. Z by itself is not really an angle, it's just a number, so I'm not putting 8 degrees there. I wouldn't count it wrong if you did, but. Okay, B says find the measure of angle GHJ. GHJ is the which angle?
The top one.
Top one, so how are we gonna find it?
You just plug it in, you plug in 8 for z, so 4 times 8
Yeah.
is 32.
Yeah. and then let's find the other little angle. What's angle JHK?
The other one, and then, so then you just do 90 minus 32.
Yeah, you could plug it in there, or you could do 90 minus 32. So, yeah. Alright,
What if we don't put a little like degree symbol?
I'm not gonna count it wrong.
Okay.
But you are.
It's enormous.
Not. Alright, 25, we're getting close, Still got 17 minutes left. This is kind of like yesterday. These are like one line of a proof that they kind of are doing part of. So on 25 it says angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. So what can we say on line 2 based on the transitive property? Angle 1 is congruent to angle 3.
Yes, sir.
27 says W is a point in the interior of angle XYZ. So we have some angle XYZ. W is in the interior. What's that mean? Somewhere in the inside. W. Then line 2 says blank because of the angle addition postulate. So what do you think we know about angle adding here? Well, if I make that an angle,
So then that plus that equals
right, this plus this equals
that.
right, that's the angle addition function. So what would the top little angle be called?
Angle X, Y, W,
Plus
W, Y, Z.
equals
W, or angle X, Y, Z.
okay, on 29, they don't tell us what the first line is, but they say on the second line, angle A and angle B must be supplementary by the definition of supplementary. So what must they have told us on the first line for us on the second line to know that they're supplementary?
That A is A plus B equals
Yeah,
90.
we must have,
180.
right, they must have told us they add up to 180. So angle A plus angle B, 180.
I can do Christmas.
Already?
Yeah.
Why?
Actually.
Some of these are tricky, so let's try and get these done. See if I remember which ones were especially tricky. I don't know. Anyway, let's try and get as many done as we can in the next 15 minutes. All of them.